Hello, this is part 3 of the preview of the TCS CS-105 Command Station. I'm going to try to make this introduction short since there's a lot to cover, and actually we're covering macros and I've already reviewed the footage and it's about 25-30 minutes, so I'm not going to prolong this. We're still in the familiar spot here. You can see the yard ladder over there. That's what we're going to work on, Command Station, and the addition is that we have a laptop here set up and it's going to run JMRI. But before we go with that, I just want to put a couple of things out about comments, and again, thank you everybody for providing comments on the previous video or videos. And then there are issues or comments about pricing of the Command Station, which was released, as well as some other things about locomotive count of locomotives that you can have in the Command Station. So the official number is actually 260 locomotives that you can have active or dialed up on your throttles and actively being controlled. This is not the number of locomotives you have stored in the Command Station, it's just how many active locomotives can you have. I don't really know anybody who has 260 locomotives active at any point in time. And the data in the Command Station, the ROS data, is only loaded into memory when you call up the locomotive from the storage. So remember, the memory is like your RAM in the computer, and the storage is the roster data that's actually stored in flash. So it's different. The Command Station is not certified yet for other markets. It's certified in US and Canada, but it will be certified in Australia, New Zealand, and then UK and Europe. It's just that apparently the process is tedious and expensive, and so easiest thing was to just do it for US and Canada first. So basically that's all I want to mention about errata on the previous videos. In part 2 I was talking about connecting JMRI over wireless, and Raspberry Pi was acting as a access point for the Command Station and the throttles and whatnot. And remember, I've used an external hub application on Raspberry Pi to do all the networking or routing packets between all these devices. And I thought that was not really an easy solution for most users, because they would have to fiddle with Raspberry Pi operating system, get a binary of the hub. I'll post a link here. And, you know, it was just not a nice solution. So I thought there had to be another way. And really, there is another way, and it's even more easier than I thought. So when you're configuring JMRI, I've used CAN via Grid Connect network interface. Originally, I was pointing it to a local host, 127.0.0.1. That's where I was running my external hub. But if you remember, CS-105 is a full LCC Command Station that also runs the hub. So as long as you point any device to that hub, it will find the Command Station. So in this case, JMRI configuration just needs to point to that IP address. In this case, it's 192.168.3.7. That's the IP address I found for my Command Station. Obviously, I mean, I had to find it, but you can set the Command Station to a static IP address, and then you can always know that IP address. And as you can see, the port 12021 remains. That's the standard open LCB port. But what happens is that you see the entire LCC network. And there is no hub running in the background on this Raspberry Pi, the application I ran, nor is there a hub running from JMRI. So this is all you need to do. Enter the IP address for the Command Station, and JMRI will automatically connect to that Command Station through wireless. You know, this opens all kinds of possibilities. You don't have to have a JMRI here. You could have JMRI in another country. As long as you can point to this IP address from your home router through your external network, get to the Command Station, you can have a dispatcher panel and a remote dispatcher someplace else. And I think it's much easier to do, and anyone can do this. So I hope this helps somebody who wants to set this up. I'd like to do a quick overview of the new setup, or improved setup, let's say. You've already seen the small yard and the KATO track that was in part 1. We still have the MRL 392. The Command Station is there. The new things are now addition of other circuits, LCC or Tower LCC, and 4 drivers for the KATO turnouts. These are DRV8871 motor drivers I didn't have the other circuits SCSD interface or board. I didn't have a free one. I have them already on my layout. So I've opted to just get these motor drivers which connect to the inputs or outputs of the Tower LCC, and then the Tower LCC connects to the command station, and you can see that it's terminated here and it's also terminated there, so we have fulfilled the LCC network requirements. And then it's a simple connection. Each motor is connected 1, 2, 3 and 4, and I will show in the node configuration the Tower LCC. And then this is basically line 1 and 2, line 2 and 3, line 1 and 2, line 3 and 4, line 5 and 6, and line 7 and 8. So we're only using half, the other half is not in use. I was considering adding block occupancy, but I don't think we need it for this demonstration or in general, because we can't really use any information from that. There is no railcom available from the blocks. The only railcom available is on the main, but I mean that doesn't really serve us anything, because you know, when locomotive is on track 2 or 3 or 4, we want to know that, and we won't because that information is not available yet. So for now we'll just focus on turnout control and see how that works with the command station and throttle, and perhaps see if we can set up some macros, and then we'll be able to control direction or align the ladder to wherever we want the locomotive to go. Before we proceed with demonstrating the macro setup in the command station, I want to say something else. While testing all this, I've ran into a weird issue where transferring the CDI or the configuration from the command station via wireless to my laptop here was going really slow. And upon checking the connection, it was running on channel 1 of Wi-Fi 2.4 gigahertz range. I think that's the default channel. If you live in a busy area with a lot of Wi-Fi stations, you might want to consider changing the Wi-Fi channel on the command station, because it might be interfered with other devices, not just Wi-Fi. I mean, because it's using 802.11g, you know, it's running in the 2.4 gigahertz range. Everything is there, you know, you name it, IoT and you know, everything wireless in a sense. So you would have to go to web UI of the command station, which is by default on the IP 10.0.0.1, and then under advanced settings you would change the channel, and I think that's here under device. And if you scroll a bit down under AP configuration, you have here channel 11. Before you do that, remember the default password was 123456789. Obviously you should think about changing the password. If you just click apply here and don't put the password into this field, it will erase the default password, and then you'll technically be locked out of the command station if you don't have something like an LCC buffer USB to connect directly over LCC, or you reset the command station to the factory settings and erasing everything that you've done so far. Ask me how I know. So remember to put the password into this field when you change the channel, and you know, I just put 123456789 because it's just a test and it's not really important at the point of me worrying about someone breaking into a command station. But really, I mean, you should have a more secure password. So that's one thing about the speed of transfer and the actual access point, because you might not notice that you're having lag because of all the other Wi-Fi devices are interfering in your neighborhood, but you will. The other thing I want to say is about JMRI, and turns out that with LCC, I mean, the intent was always to use JMRI to configure LCC, and so you will have to, I guess, set up JMRI on your laptop or computer and connect it wirelessly to the command station to perform configurations of both the command station or advanced configuration of command station and any nodes in your network. For example, the UWT throttle, I'm told, is never going to be able to download the configurations of other nodes so that you can configure these nodes on the throttle. It's just the throttle is not powerful and not interface on the throttle is not adequate to do something like this. And if you've seen some of the nodes that we have from other circuits, I mean, you know, there is a lot of stuff here that you would have to configure, and loading something like this into a throttle is just, you know, forget it. So JMRI or similar program that can edit CDI, the configuration description interface, will be needed basically if you want to do anything serious with your LCC network. Now, there are other things that are in the works that can edit CDI, and I think I hinted at it or mentioned that in one of my videos on my own layout, and I might actually show that in another video, not this one. So I'll just leave it at that. Let's take a look at the setup on JMRI for the Tower LCC, connecting it to the 4 turnouts that I have and double crossover in that little yard I made in the layout. So, I mean, this is not a tutorial really, and it's not about Tower LCC or doing this, but it's still part of the process. So I'll just, you know, fly through this. So I have 8 lines connected to Tower LCC, as you can see here, line 1 to 8, as I mentioned in the previous segment. Line 1 and 2 are double crossover, and the way it works is that you have to send a pulse, active pulse high, and you have to make sure that you disable the input function. This is imperative, right? So only sending output pulse. And then you have to set up the interval. Interval 1 means 0, start immediately. Interval 2 is how long the signal, the pulse should be, 100 milliseconds, right? This is 100 milliseconds, that's a unit. And we're not re-triggering it. And then under event, you can see down here, here is the event ID. So when this event triggers, then the line goes on, meaning throw the turnout. And then in the event number 2, the line goes off. And then for the line 2, same thing, you know, sending the pulse up here, you know, interval 1 and 2, and then again, event 1, turn the line on, and event 2, turn the line off. So basically, what happens is then when you trigger the line 1 via the 0001, oops, sorry, 00, it will throw the crossover, and then when you send 0C, it will close it back. And the same thing goes for all the other. So I have turnout 1, turnout 2, and turnout 3. Same settings apply. And then, you know, you would do, let's say, double crossover. In the turnout creation, you would paste the active or thrown and closed events, which is the 00 and 01. And then you would create that turnout in JMRI, and then if you look at the panels, tables, turnouts, you can see here that I have those two. Well, actually, it's 0C to it's 0C to close the double crossover, because you have to pass the 6 events first for the line 1, and then get to the event for line 2. So anyways, I mean, when you, right now it's in the state of closed, and you've heard it throw, and now it says thrown, and then if you close it, it just sends the packets back, and you can see that in the network monitor. You can see there the packet goes. See, it sent 0, then close it, send C. And the same happens for all the other turnouts. But I mean, as I said, this is not really a tutorial how to do this. This is just demonstrating that this is set up here because we need these events, and we'll plug these events into the macros in the command station so that we can execute them from the throttle. I'd like to add to the previous segment about configuring Tower LCC with your turnouts that you don't need to use macros of the command station to throw your turnouts. Matter of fact, using macros is really not necessary. Even the command station is not necessary. As long as you have an LCC network and a hub, and this UWT throttle can connect to this hub and the rest of the LCC network, the throttle will throw what's known as a well-known event in the DCC accessory range when you call up any DCC accessory address. And I'd like to show this event here, how you can add it into your Tower LCC, just so that it's clear that it's one of the options that you have that you can use to throw your turnouts without setting up macros in the command station. Because this event is universal, it's associated to the DCC accessories. The drawback, I suppose, or the catch is that you can only have 2046 of these events or addresses. But if you have less than 2046 turnouts in your layout, I think you should probably be good to go. So I'll just change the double crossover that we have here, if you remember in the previous segments. So we're just changing event 1, and event 1, the address should be 0101 0200 FF00, and then the first, so there should be 2 zeros FF00. So the first DCC accessory is always number 1, but here it does start with 1, it's actually 8. And I'll display the formula on the screen of how you compute this. The first number is the throw, and then the next number sequence is the close. So for this accessory address 1, this is the event ID. So it's 0.8 or 08. Oops. It's 08 for throw, and 09 would be for close. So I'll write that, and I'll just copy it. And so in the event for the close, we need to put 9, right? Because 9 closes, but 9 also activates the second line. But remember, then we need to shut off the first line, so we'll put 8 here, and then in the other, in the first throw, in the throw second event, we'll have to do 9 there as well. So basically they're just crisscrossed. So what happens is that when an event with the address ending in 08 occurs, then the first line, line 1, will throw live, or line will be on, but the second line, line 2, will be off, because that's the event we put for the event 2. And the other way around, when the event with the ending on 09, or the DC accessory address 1, is broadcast, then line 2 will activate, but line 1 has to deactivate, and thus the event 2 on line 1 will trigger. And just to demonstrate that we've already programmed it, you would pull up the DCC accessory, remember, and you already have one here, and you can hear the turnout throwing. And basically that's it. You don't have to configure anything else. You already have the functionality of the DCC being translated basically into LCC here, because the turnout is listening through a Tower LCC, and I'll show you the actual traffic monitor, and you can see when I throw what happens. You can see that the address is being broadcast there, and it's broadcasting 08 and 09. So you would basically program all the other addresses in your Tower LCC or whatever other consumer of events to this well-known address if you want to use the DC accessory address range from 1 to 2046 and not really use macros. Macros are useful for other things when you want to connect multiple events together. But technically, Tower LCC also allows you to chain events as well. One place where I see where you wouldn't want to code the well-known events is, let's say you're part of a modular club. You know, at home you've programmed your module, it has a couple of turnouts, let's say, and then you program your module to answer on DC address 1, and then you go to a meet and then connect your module to the rest of the modules with LCC and whatnot, and then somebody else actually also had connected their or programmed their turnouts on the same DC accessory address. And obviously you know what's going to happen. You know, somebody throws DC address 1, all of your turnouts are going to throw or close. So that's one of the times where you don't really want to program this the well-known event into your towers. That's why all these nodes have their own unique addresses so that they don't clash. Let's now look at setting up a macro on the command station. For this we'll need the events from Tower LCC, and I'll open the Tower LCC configuration so we can copy and paste from that configuration the relevant event IDs. I'll just put that here. We'll just set up the double crossover. You can see here that I have those two lines, and here is the event address we'll need. And then the other thing now. We'll open the command station configuration as well. And in the command configuration, we'll open up the macro settings. Just make this smaller a bit. And make that smaller a bit. Not too small so that we lose the address. Okay, event ID. Hopefully you can see this. So here are the macros. The way it works is that the macro number 0 is the one that executes at the boot up of the command station. You can see it here. Let's say you want to do something like power up certain tracks in your staging, line up turnouts, or I don't know, turn the lights on in some town or something, or any number of things that you can think of that you can drive through LCC and the nodes you have on your layout. You can bunch together in these macros, and then the moment you turn your layout on and your command station, all of these things will happen. So that's basically on boot up. And then the next macro is macro number 1. And to actually edit the macro, you have to go here and then you would write 1 into this field, which tells the editor that you want to edit macro number 1. So I'll say write. And then once this save changes, oh, you don't see it. To move the camera a bit. Once the save changes button here gets shaded, it means it's ready to say refresh all, and now you can see that number 1 has been loaded into the editor. So we'll call these double crossover throw. The standard trigger is the event that triggers this macro. Let's not forget to write this. Important thing about this, I mean, if you don't know it, that you have to write, when you change the field, you have to write it back. If you forget to write it, it's not going to be remembered because this is a stateless system. You have to tell the other side, whether it's a node, whatever node it is, or command station, or whatever device you're communicating here, that you actually did change something. It doesn't know that you've done this just because you've altered the field. So remember to write. So standard trigger is the event that will trigger this macro. This event ID is universal for all command stations. Universal meaning that all command stations use the same event ID pattern, meaning that 09009 and FE 0001 02 03 and so on. Each command station will have the same sequence. So in this case, let's say this macro is 01 and it's allowed to run. Trigger now, we're not going to trigger because we didn't set up yet. Step 1, you have 10 steps in each macro. And these steps have a number of commands that you can execute. And these commands you can see here. You can throw a turnout, normal, reversed. These are really events that are being broadcast. What I mean is that when you say throw normal, the macro will broadcast an event into the LCC network, the well-known event that corresponds to this accessory address that you've entered in the field, in the next field here called number. So if you pick these two, that's what will happen. The next one is send LCC event, and you have a link macro. Currently that doesn't work, but it will. And you can chain macros so that, let's say you have macro number 1, you have 9 steps in it, and the 10 steps can link to macro number 2 that can execute another 9 steps, and then you have in steps 10 and macro number 3 and whatnot. Select local DC short, long, select local LCC. These allow you to select a local by its DC address. And why is that important? Well, because in the following commands, sequence of commands, you can actually control locomotives. So let's say you have a commuter or something and you want to make it run from one station to the other, you can set up a macro for that and it will just automatically go back and forth at certain speeds that you set up. What's missing here is a delay, and I'm told the developers will try to add this feature in preferably before the release of the command station or very soon after the release. It might be like a firmware update, or it will definitely be a firmware update. And then local function on and off, that's basically, if you want to turn the lights on or off or toot a horn or something. And invalid macro, I'm not sure what that is, so I'll just skip it. So let's say in this case, we want to send an LCC event. Number, well, we don't care about that, but the event number, so let's not forget to write. This is the event that we want to broadcast. So then in the other screen from the RR circuits node, we're going to copy this event here and then paste it here and write. And this macro is done. So let's set up another one where macro number 2 is going to close the turnout. So you would say 2, write, save changes got shaded, so it's done. And then you say refresh all, and you see the field is now empty. So we call it double crossover close. And we write that. And then again, in step 1, we'll say send the LCC event. And then here, whoops, sorry about that. We want the other line event, which is ID. This is the event ID we want, 0C. And you just paste it here. And then you say write. And that's that. So now you just go to the throttle and you select the TCS accessory button here. And you would put 0 for macros, and then you would call macro number 1 and execute it. And there the turnout true. And if you call up macro number 2, remember we select to close, and it's closed. So basically that's what it is. Through these macros you can chain the entire yard ladder, and I'm going to set that up next, and then I'll show you how that works. But this macro can also throw a turnout and then get a dwarf signal changed and power the track on, or whatever sequence of events that you want to program into this macro. You have 10 steps, or 9 plus the 10 step would link to another macro, and then it can execute another 9 steps and then link to another macro, and so on and so forth. So you see where I'm going with this. So we're just going to go back and take a look at the JMRI again, and I'm going to just pause the video, and in a blink I'll have everything else set up. So we are back now, and I have the sequence for track 1, 2, and 3 in my yard programmed as macros, and I also have a macro number 10. I'll show you that actually resets the yard back to normal. And so if you scroll here, you can see that I'm calling macro number 4 in step 1, and that corresponds to line 4, which is turnout number 2, or the yard throat, close. We previously, remember, I mentioned lines 1 and 2 on my Tower LCC are the double crossover. Line 3 and 4 are the throw turnout in the yard. 3 is throw and 4 is close. So the macro 4 corresponds to close. And then in step 2, I'm calling line number 6 or macro number 6 corresponding to line number 6 on my Tower LCC, which closes turnout 2. And then step 3 does the same thing for the number 3 turnout on line 8. And if you take a look at the, let's say, macro number 12, I just programmed them in such a way that, you know, track number 1 is 11, track number 2 is 12, and track number 3 is 13, macro number, right? So, you know, if we refresh all, we're looking at macro number 12, and it says yard track 2. What does it mean? Well, step 1, throw yard throat. Obviously, we want to enter the yard. And then step 2 is we're lining up for track 2. So we want the track 1 turnout, that, or turn number 2 that goes between track 1 and track 2 and 3 closed because we are continuing past it. So that's why 6. And then in step 3, we are throwing turnout number 3 because we want to go towards track 2. So let's just see how that works. If we go and in the UWT, right now you see that the yard is all closed. The throat is closed and then all the other turnouts are closed. So if we call up 0 for macros and then we say 12 and say select, all the turnouts should line up for track 2, and let's check. So throat is closed, thrown. So we're entering the yard. Turnout number 2 is closed, so we're passing track 1. But turnout number 3 is thrown, so we're entering track number 2. And then if we go back here and say, well, we want to reset the yard to all closed, we'll just put number 10 in the macro and say select, and everything is back to closed, and you can see that. So the shadow close, close, close. And basically, you know, if your yard is much bigger, or you have a staging yard or something else, you can do this, and you can call this from control panels, you can call this from JMRI, you can call this, it's just like routes, you can call it from your dispatcher's panel. If your dispatcher's panel is fully LCC capable, a dispatcher can just press a button, it will throw an event, and all of these things will line up in your staging, and a train can be ready to depart your staging or whatever. I think you're seeing the potential of these macros, just like in other systems, older DC systems, you would have the routes or whatnot, but this is like really taking it beyond that because you have access to all these nodes that do all these other functions and such. So before we wrap up, I was thinking to actually see how all this works together and do a little operating session, shove some cars around. Let's go to the yard and do that. So here we are in the yard, and let's just get the 392 on the track and go down and see what we can do. I have a few cars set up on, let's say this is an arrival departure track, so we can get these hoppers, covered hoppers, and put them on track 3, and then get the box car and get the other 2 hoppers from track 2 tied into a train, and then put them back onto the arrival departure. And we can just see how these macros work. I have decoupling magnets on my tracks, which I think, in my opinion, makes it easier to do any switching rather than having to use bamboo sticks and whatnot. So we're just going to pass the yard throat, and then we're going to execute macro number. Macro number 13, because we want to go to track number 3. And everything is lined up for us, so we escape from that and just get our small train moving. And we'll just go to the magnet and then decouple there, get the boxcar, and then get the 2 hoppers next and get back onto the arrival departure. So just pass the magnet, create some tension there. And there we go. Now we want to go to track number 2. We could call the macro 12, or we can call macro 2 to just throw turnout number 2. It doesn't really matter. So we just do 12 here, and that does that. And then we go back and grab our boxcar. Okay. And then we go do the same thing with the track number 1. We need those 2 hoppers over there. And we go back again and say 11, select, go back, couple to our hoppers. There we are, and we just take out the yard and get here onto the arrival departure track, and we are ready to leave or decouple the locomotive, wait for the road engine or something to come and get these cars or whatever. And since we are leaving the yard, we want to just reset the yard back to closed, so I stop here and call up macro number 10, and then say select, and everything gets closed. So escape there, and we go back. And almost there, and we can just stop here and power down. There we are. I hope you like this video so far. We'll see what happens in part 4. I'm hoping to do probably some programming on the main and talk about some cost testing. Until then, thanks for watching.